Hello, everyone. Welcome to JTAC's educational webinar on how to choose the best RFID tag for your application. My name is Justina Valencia, and I'm part of the marketing group here at JTAC North America. On the line, we will also have our Director of Global Marketing, John Pryor, who will give us a brief overview of JTAC and our parent company, Noventa, before handing off the mic to our RFID Product Manager, Steve Schneider. Today, we will review the types of factors you will need to consider when picking an RFID tag for a medical device or consumable, which types of special RFID tags are available on the market to cater to your specific applications, best practices for choosing an HF or UHF tag and reader combo, and other options available for rugged applications such as sterilization or extreme temperatures. We encourage everyone to type in your questions you may have during the webinar into the chat or QA window located at the top right-hand corner of the presentation, so I can read your questions out loud to Steve. We'll do our best to answer all of your questions. However, if time does not allow it, we will follow up with you regarding your questions once the webinar has finished. At this time, I'd like to hand the mic off to our VP of Global Marketing, John Pryor. John, take it away.
Thanks, Justina, and good afternoon, everyone. As Justina said, my name is John Pryor, and I'm the Director of Marketing here at JTAC, and I'm going to do a brief introduction to JTAC before I hand the mic over to our featured presenter, Steve Schneider. So we're going to start here. Who is JTAC? And JTAC really specializes in embedded machine vision, RFID barcoding, really embedded data collection solutions, and primarily for the medical device manufacturing industry. We do have products that can be bought off the shelf, but generally what makes JTAC a little different than your more traditional data collection providers is that our customers are typically coming to us for more optimized solutions, and those solutions are generally engineered to meet project-specific needs or customer-specific needs and requirements for certain projects, which is obviously especially important in the medtech OEM industry and for those customers there. Which leads me to the next area where JTAC is pretty unique, and that's really our dedicated focus to the medical OEM market. Rather than having sort of a multi-market approach or solutions that are well designed for maybe other industries, but not necessarily for healthcare, we've made the strategic decision really since the inception of the company almost 20 years ago to focus solely on the medical OEM market. So today, approximately 90% of our business is with medical device manufacturers. We are 13485 certified as well as 9001 certified. And we're really the experts in embedded or integrated RFID and machine vision solutions for the healthcare market. We are the #1 leading supplier today of imaging engines to the healthcare market overall, most prevalently in the blood glucose and portable analyzer and infusion systems markets. Additionally, the majority of patient monitors in the field today, as well as ultrasounds and infusion pumps, utilize our hand scanner, and that's the HS1 or HS2. As you can see here down to the right, bottom right image is scanning an orange pill bottle. That's our HS1, and those are pretty prevalent in the patient monitor world and ultrasounds and infusion pumps. And we're actually the first to embed machine vision solutions in many medical devices in the field today, especially clinical analyzers. So we're really pioneers in this space, and we've been doing this for, like I said, almost 20 years now. Moving on to the next slide. So our parent company is Noventa. We are a wholly owned subsidiary of the Noventa Group. Noventa is formerly GSI Group, if anyone was familiar with that company. We were acquired back in 2014. The Noventa business is approximately $400 million in overall revenue. We have about 1,400 employees across the globe in worldwide locations. And Noventa, as you can see here to the right, is really set up in 3 different technology segments. So you have the photonics or the laser group here on the left of this model, that division offers high-performance solutions for laser-based surgical, analytical, and fine material processing applications. Over to the right of this model, you have our precision motion group. So this group offers solutions such as optical encoders and direct drive motors for motion control applications. So really what you want to think about here is a good example would be robotic surgery. So in a robotic surgery application, those robots are moving in sub-micron, sub-nanometer levels to make sure that robotic arm is doing very, very precise movements and making very, very precise cuts or whatever that machine is doing. So that's really what that group is responsible for within Noventa. And then, of course, the vision group where JTAC sits today. And our goal there is really focused on providing solutions that give advanced industrial and healthcare OEMs a competitive advantage. So I'm going to stop there, and I'm going to hand the mic back over to our featured presenter, Steve Snyder. Steve, you can take it away from here.
All right, thank you, John. As John said, my name is Steve Snyder. I'm the RFID Product Manager for JTAC. I started in the RFID industry about 5 years ago with JTAC. We were primarily focused on providing RFID modules to manufacturers. Some of our best customers were definitely medical device manufacturers, so it's a really good fit when we were actually acquired by JTAC about a year ago. And I've actually been with JTAC as head of the RFID product line since then. So I've got, I went to school for civil engineering, kind of moved over into this more kind of RFID world. It's really exciting, really a lot of cool things that we can do with RFID. So with that, we're going to go ahead and jump into some goals of this overall webinar. So by the end of this webinar, we hope that you should be able to have a high-level understanding of the RFID tag industry, basically who the main players are in the industry, what the different components of an RFID tag are, how they all work together. It's really meant to be an introduction to the RFID tag industry so that you can understand how everything works together and have a high level of the tag industry, and then also feel comfortable with where to start when beginning your RFID tag evaluation. So as a quick summary of our agenda today, John, thank you again for doing that introduction to JTAC. I'm going to jump into an RFID technology overview. Then we're going to discuss kind of the major players in the RFID tag industry, how they work together to provide a tag that's ready to use in a live system. After that, we'll go to some RFID tag best practices, tag selection best practices, and then we'll finish with a kind of start to finish example of how a company would walk through our best practices and kind of do it step by step and really explain what you should be considering during which step of those best practices. So jumping into the RFID system, so there are 3 parts to a passive RFID system. There's a host, some type of host, some type of reader, and some type of tag. In the example shown here, we have a laptop that acts as our host, which communicates via USB to a reader and antenna. So we have the laptop here. I guess my pointer isn't working, that's okay. The reader system then communicates via passive RFID by sending radio waves over the air. And the radio waves then power the tag, which in turn sends the tag data back to the laptop. So let's take examples of a host, a reader, and a tag. So first, on the host system side, as we said, it can be anything that controls the RFID reader. It can be a desktop computer, some kind of network device, or even, that could be a server or anything else, a Wi-Fi connected device, anything like that. Or it could be as low level as a microcontroller that would actually be built into another device and control the RFID portion of that device. The reader portion of the RFID system really includes 2 similar parts, the actual reader and an antenna. Some RFID readers do have antennas built in, while others do not. In the example shown here, the RFID fixed reader would communicate via USB to a computer, and that would require an external antenna which would connect over those ports that you see here to communicate with the tag. The RFID handheld in the middle there, on the other hand, actually has a built-in antenna, which would allow it to just be a single unit that would then be able to communicate with an RFID tag. And then the last examples we have here are RFID modules, and again, that's really where SkyTech specialized and what JTAC is really kind of focused on as far as selling to medical device OEMs. And RFID modules can either include internal antennas or only support external antennas, depending on the model type. All right, and then we're going to finish with the RFID tag. So the RFID tag, that's what the focus of today's webinar is going to be on. This is the third part of our RFID system. The tag itself is comprised of a microchip, which we'll be referring to a little bit later as an IC, or integrated circuit, tag IC. That's really the brains of the RFID system, and then an integrated antenna, which allows that microchip or tag IC to receive and respond to signals sent by the RFID reader. So today we're focusing on passive RFID technologies. In the passive RFID world, there are three types of passive RFID. There's LF, or low frequency, high frequency, or HF, and ultra high frequency, or UHF. But for the purposes of this discussion, we're going to focus just really on the two that were most prevalent in the industry today, which are HF and UHF. So in general, HF RFID is best for applications that require a short read range or those that require a little bit more data to be stored on tags. There are exceptions to that rule, but in general, that's kind of adheres to that standard. UHF is better for longer ranges or applications when you're trying to read many tags simultaneously. So on the HF side, the most common examples that we see are key fobs that allow contactless access to buildings or offices or things like that. You may also see HF RFID inside of some library books that have implemented RFID tracking systems. It's also the technology used in NFC cell phones. UHF, on the other hand, is best known for its use in retail and apparel. Originally started with the Walmart declaration back in the mid-2000s that all items that Walmart received were going to have RFID tags. That didn't quite take, but 10 years later, we're really starting to see RFID really expand quickly and rapidly in the retail market. We also, I know Vail Resorts, who is expanding as one of the largest ski resort operators in the nation, has built RFID into all of their lift passes, both for customer engagement and to kind of ease the actual access control of skiers onto the lifts. And then on the airline baggage tracking, Delta very recently actually announced that they will be tracking every single bag with UHF RFID. We're going to skip the technical details, but if you have questions on either of those technologies, feel free to submit them and we'd be happy to address them at the end of the talk here. So now we've gone over a high-level look at technology, the RFID technology as a whole, we're going to dive a little further into the RFID tag industry to understand a little bit more how the different manufacturers work together to provide a tag that's ready to use in a live system. So we're going to take a step back here. When we just looked at this slide a second ago, but I wanted to add a little bit more detail. The RFID tag in this picture is composed really of three parts, even though we kind of touched on two parts just a second ago. The microchip, which we'll be referring to kind of from here on out as the tag IC. IC meaning integrated circuit. An integrated antenna is another part of that tag there, which again absorbs the antenna radio waves, or absorbs the radio waves from the RFID reader so that we can power that tag IC and communicate back and forth with the RFID reader. And then we need some kind of substrate to hold that antenna and microchip together. Generally that substrate is some kind of silicone, although it can be many different types of material. The tag shown here is really what we would call a tag inlay, which we'll get into kind of the details on that in just a second. But in general, we would call what we're looking at here a tag inlay. Over the next couple of slides, we're going to dive into the parts of this tag in a little more detail, as well as review some applications that would build on top of this basic construct of a tag inlay. So with that, we're going to kind of take a step back and we're going to focus just on the IC of the tag, which really is the brains doing the heavy lifting of the RFID tag with our little diagram there. So it's really the tag IC is really what determines the technical features of the tag. The IC manufacturers will build these and then generally send them to an inlay or a specialized tag manufacturer. So we'll go in, like I said, we'll jump into those in just a second. But the tag IC really determines the operating frequency of the RFID tag, so that in our case with HF or UHF, we'd be looking at 13.56 megahertz for HF or 860 to 960 megahertz for the UHF band. In the United States, that's a little bit smaller band of 902 to 928. As far as the tag IC defines the air interface protocol, which what we're really describing there is the language that the tag speaks in order to communicate with the RFID reader. So examples of those protocols, on the HF side, you might see ISO 15693, ISO 14443. On the UHF side, you might see some of those tag languages or air interface protocols referred to as ISO 18000-63 or EPC Class 1 Gen 2. Again, if you have more questions on those, feel free to submit them and we'll try and answer them as we go forward. Don't want to get stuck too far in the details here though. The tag IC would also define how much memory is available, which, we'll be talking about the length of the identifier, which in and of itself can be changed, as well as how much user memory is available. If there's any secure features, anything like sensor capabilities, some tags actually are able to sense moisture, temperature, or pressure. And then some stabilization requirements require kind of some technical capabilities of a certain type of tag. So from the tag IC, we have an inlay manufacturer. So an inlay manufacturer would actually purchase the tag IC from one of those tag IC manufacturers, put it on a substrate, and add an antenna. So the antenna design would be influenced by the frequency of that tag. So at the 13.56 megahertz frequency, you'd be looking at a tag like this one here. It'd be some kind of coil that inductively couples to the RFID reader. So if you were trying to compare a HF tag or a UHF tag, generally if it's some kind of coil, it can be in a square, rectangle, or circle shape. It's going to be an HF or potentially even an LF, but generally more often an HF RFID inlay. If you see something that kind of has some squiggles and maybe a more complicated, little bit more complicated overall design like this one, it's probably going to be a UHF RFID inlay. Really that just comes down to the technology that these tags are built on. So like we said earlier, the substrate that's built into these is most often silicone, but it could be some other type of material. We've actually even seen paper tags where they use conductive ink to actually connect up the tag IC and to the antenna. And then generally these tags can be sold directly to a customer, but probably more often they're sold to a label converter, which we'll get into right after this. Some examples of customers that might use a tag inlay as is directly from a tag inlay manufacturer would be maybe a library, maybe a medical device manufacturer, but really it's any type of application where the appearance isn't critical, where we don't need to hide the fact that we're using an RFID tag in this application. So with that, we're going to move on to tag converters. So tag converters take those inlays that we just discussed and build them into a finished label. These are probably, most likely, if you've seen RFID tags, they're some type of converted tag. So a tag converter adds a label outside of the RFID that allows the tag to be printed on and most often become more durable. So for instance, this could be a retail clothing tag, a hotel key card, any type of NFC sticker, access control badges, wristbands at concerts, anything like that. Often if you see the word smart in front of something passive, so if you see like a smart wristband or a smart tag or something like that, it's an RFID tag that has been converted into some kind of finished label. So with that, we're going to move on to specialized tags, which is a whole another kind of industry in and of itself. If you have an application that requires any sort of ruggedness from an RFID tag, you'll want to purchase your final tags from a specialty manufacturer. Depending on the company, a tag manufacturer could either purchase an inlay and build some kind of ruggedness around it, or build their own antennas and purchase the tag IC and really kind of take that from the ground up. The tags kind of vary greatly across the whole spectrum, but if you have an application that you need an RFID tag for, a rugged application, then there's really a good chance that there's one built specifically for your application. So some examples here, any kind of mount on metal tag would be considered a specialized tag. You do need special tags if you are planning on mounting your RFID tag on a metal canister, on a metal surface, because if you use a normal inlay, it will actually affect the radial properties of the tags and make it almost unreadable. If you have a special sterilizable tag, there's many autoclave tags on the market. There's gamma and ETO tags on the market. Most tags can actually survive vaporized H2O2, but you still want to make sure that you have a tag that can meet those temperature specifications. If you need an ultra-durable tag, there are even tags that look like screws, like this guy up here, that has an RFID tag built into it. It can basically it's IP68 rated, can be subject to all kinds of really high temperatures, high pressures, drop zones, things like that. There's durable tags for plastic containers. There are tags that can be washed. The point is, there's a lot of different type of specialized tags. It's a pretty broad market. But again, if you have a specialized application you need an RFID tag for, there's a good chance there's a tag that's already been built specifically for your application. And if there's not, there are a number of manufacturers out there who, even at small volumes, can offer customized tags.
Hey, Steve. Yep. I had a question that just came in. Can I read an RFID tag through liquid or metal? And which UHF or HF is better for one or the other?
Yeah, so if you're looking to read an RFID tag through metal, you're not going to be able to do that, but you can read tags that are mounted on metal. The metal basically would just actually totally block the RFID signal. Through liquid, you might be able to read through short amounts of water, small amounts of liquid, so something like an inch or so, and I think that HF RFID would actually be better for that type of kind of application where you're trying to read through liquid at any given point. All right.
Thank you.
Yeah, thank you, Justina. All right, so with that, we're going to kind of take a step back and kind of just bring all together of this whole tag industry, because there are so many different manufacturers that work together to create a finished tag that actually makes it into the end user's hand. So we start at the top with IC manufacturers. Again, the IC manufacturers are really the technology leaders of the tag itself. They build in the user memory, the RFID technology, the frequency at which the tag works, any secure features, everything like that. That's all determined by the IC manufacturer. Those manufacturers then sell to inlay manufacturers who basically make a tag, make it so that the IC can actually be read by an RFID reader by adding an antenna. Those guys in turn could sell to a converter or directly to a customer. Converter, again, would take that inlay, add some kind of covering around it that could be printed on, any kind of custom printing, as well as actually add some durability and sell directly to the customer. IC manufacturers could also sell directly to specialized tag manufacturers who would then basically sell directly to a customer. There are many exceptions to this kind of very simple flowchart, but hopefully this helps kind of bring it all together and helps explain how everything works together and creates a final product that can be delivered to you, the end customer. So with that, we're going to move on and actually go over some best practices for choosing an RFID tag. So we've broken our practice down into 5 steps. So 5 steps to choose an RFID tag for application. So first, we recommend that you conduct a thorough needs assessment. So in this phase, we're recommending that you ask yourself and ask your team, what are the end goals of the project? Why do I think RFID will be the best fit for my application? What kind of environment is this tag going to be subjected to? Is it really harsh? Is it sterilization? Is it something where we're going to be up to 150 degrees Celsius, or will it only be, 50 degrees to 75 degrees Celsius? What range do you need from the RFID tag to the RFID reader? Do you need only 1 inch, or do you need up to 10 meters? That'll greatly affect the technology that you choose. Again, for longer ranges, you'd probably want to trend more towards UHF. For shorter ranges, probably more towards HF. You know, you want to ask yourself, does the information on the tag need to be secured? Are you worried about some other user reading that tag and reading the memory on that tag and seeing the secure information that you're storing on that tag? What is the maximum physical size of the tag that you can use? You know, can your tag be 6 inches by 6 inches, or does it need to be 10 millimeters by 10 millimeters? Then finally, you want to ask yourself, you know, how are we physically going to affix the tag to the item that we're tagging? You know, is this something that just a simple adhesive will work, or do we need to screw it on because it's going to be out in the field? Any kind of rivets, anything like that. You know, this step is meant to help you start thinking about the RFID tag, which in turn takes you to the next step, where we recommend that you actually choose your RFID reader. The reason we recommend you choose your RFID reader before you choose the RFID tag is because if you do this, it's possible, you know, if you choose not to choose your RFID reader first, it's possible that the tag you choose won't be supported by the reader you'd like to use. It's possible that it'd be very difficult to find a reader that supports all of the secure features or all of the unique features of the tag IC that you'd like to use. And it's also possible that if you've found a tag on the market, it could be difficult to get the maximum read range out of the tag that you chose. So by choosing an RFID reader first, you'll be able to lean on the expertise of the reader manufacturer to help you choose an optimal RFID reader and tag combination. So when you're looking for an RFID reader, you want to find a supplier who supports a variety of different types of tags. And that's especially true in the HF-RFID world, where there are so many different tag standards out there, and so many different types of tags, and so many different proprietary security features, and different memory sizes, everything like that. And you want to find an RFID reader manufacturer who has a platform that allows for the ability to add features to non-standard tags, for non-standard tags. So by that we mean if you have tag A that has secure feature B, but your reader manufacturer only supports tag A with secure feature C, you'd like to know that your reader manufacturer can change and kind of work with you and customize a solution that will allow you to support every single thing that fits your needs. So once you've kind of gone through a needs assessment, chosen an RFID reader, then you're ready to start getting some tag samples. So we recommend that you test multiple tag IC types, as well as multiple tag shapes and form factors. And we'll go into kind of what that specifically means in a little more detail in our example. And once you have a couple tags, you'll want to start testing. And when you start testing, you want to verify that you have an environment which truly simulates the tag environment when it will be deployed. You'll want to check the reader and tag range. You'll want to check it while you're reading the ID, while you're reading memory, while you're writing memory, because some of those can affect range. You want to verify that the security features are working, both on the reader and tag size. And if applicable, you want to test the tag after subjected to sterilization, after subjected to any kind of high temperatures, any ruggedness, any banging, any kind of drop testing. You want to test the tag after subjecting it to those, just to make sure that you're thoroughly testing. Once you've tested, we really recommend that you repeat the process at least once. You know, maybe see if there's some other tag samples. Just use what you've learned in the testing and obtaining tag samples phase to go back, reevaluate the tag landscape, make sure you've got the best tag for your application. You know, I think you could sit here for a while iterating, just make sure that you have the best tag. You know, there's even pricing considerations that you want to jump into, all of that. And once you've tested, you're ready to start planning deployment. On deployment, you'll want to answer questions like, who's going to do the final printing of my tag? What information is going to be included on the outside of my tag? Is that a barcode? Is that text? Is it a picture, etc.? You know, do I need to, if I'm planning on doing the printing myself, do I need to buy an RFID tag printer? You also want to ask yourself, who is going to pre-program the tags, if anyone? Lots of times we have customers who like to have some reader memory pre-programmed with some kind of set features, such as an expiration date. You also want to ask yourself, you know, what information is going to be included in the tag memory? And finally, who's going to actually affix the RFID tag to the object? Who's actually going to put the RFID tag on the item that we're trying to tag? All right, So now that we have our 5 steps for choosing an RFID tag, we're going to go through a quick example of our theoretical company called VeriAnalyze. In our theoretical company, VeriAnalyze, they actually manufacture clinical devices that use proprietary reagents. So VeriAnalyze wanted to come up with a proprietary reagent tracking system. The overall goals of the system are to make sure that the reagent is identifiable by RFID, barcode, and some kind of human-readable text. They want to prevent counterfeits and prevent low-cost consumers. We want to make sure that our reagent bottles are only used once. That's to make sure that our customers or any kind of counterfeiter isn't taking the bottle that shows that it's been used and refilling it. By doing that, we want to track the amount of reagent inside of that bottle. We want to make sure that and finally, we want to make sure that the reagent is not used after its expiration date. So going back to our quick steps to choose an RFID tag, again, we want to conduct the needs assessment, choose the reader, obtain tag samples, test, iterate, and then plan our deployment. So we're going to break this down into kind of a needs assessment for VeriAnalyze. So the original request, kind of summarized, was they wanted to be able to read the barcode we want via an RFID, barcode, and human-readable way. We want to prevent counterfeits. We want to ensure that the reagent bottles aren't being reused. We want to make sure the expiration date is enforced. And then we want to read one tag at a time at a short range. So what does that mean in kind of RFID speak? We want to make sure that the RFID tag can be printed on. We want to make sure that the tag IC has some secure features in order to prevent those counterfeits. We want to make sure that the tag IC has significant memory. The reason for that is if we're logging every time the bottle is used, for instance, if a reagent bottle has 100 mLs of liquid inside of it, and each time a test is completed, it uses 1 mL of that liquid, it would log that in the tag IC. We need to make sure that we have enough room for that to be logged at least 100 times. We want to make sure that to prevent use after the expiration date. We just need enough room to lock an expiration date on the tag. And then to read one tag at a time at short range, HF RFID is probably our best option here. So then if we went through this with the engineering team, we could find that more technical requirements, specific tag requirements, we find that in order for a tag to be RFID, barcode, and human readable, it needs to be supplied by a tag converter, which we touched on earlier. The tag IC would need to have password protection in order to prevent those counterfeits. There are different levels of security there. For instance, the customer could have said, VeriAnalyze could have came to us and said, they really want to make sure that they have AES encryption. That's possible as well. In this case, they just want to make sure they had just simple password protection. The tag IC, to ensure the reagent bottles are not reused, we want to make sure that the tag IC has at least 1 kilobyte of user memory based on what the engineers have told us. And same thing, that 1 kilobyte would actually include enough room for the expiration date. And then with HF RFID, we want to make sure that our tag adheres to kind of the main standards for HF RFID, either ISO 15693 or ISO 14443. So from the needs analysis, if we think about this, we're going to our next step, which is our reader selection. At a high level, we need an HF RFID reader that supports a tag with either 15693 or 14443 compatibility, has password protection, and has at least 1 kilobyte of user memory. So this is where JTAC can help. We can help provide the RFID reader, as well as help connect the correct RFID tag suppliers in the market. So after that, again, after you've chosen a reader, you want to obtain some tag samples and test. So we recommend that after choosing your RFID reader, you find 2 to 3 suppliers of RFID tags, and then you get samples from different vendors with different form factors with different tag ICs. The reason for that is, sometimes there are subtle differences even just between the over-the-air protocol, the tag IC itself, that can really affect range and performance, everything like that. So we recommend that you, for instance, could test form factor A with IC1, form factor A then with IC2, and the same thing with B with a different form factor and with 2 different ICs. You want to make sure, again, as we touched on a little bit earlier, that you are testing the reader and testing the tag together in the true environment. You want to test reading, writing, locking, everything that you would need to use and plan to be able to use in the future in a true deployment. Then once we've kind of tested, we want to make sure we repeat if necessary. You want to make sure that your requirements haven't changed over the time as you learn more about RFID. You want to make sure that the current tags are meeting expectations, and if they're not, find another one. And maybe there's some additional tag features. Maybe VeriAnalyze could actually find that they need 2 kilobytes of tag memory because they'd like to track some additional information about the reagent. So that's why it's always good to consider iterating and taking new tag samples, again, in different form factors, test them with different ICs. And again, this is something where JTAC can help you work through this, help you create this process, and help kind of move forward in this whole world. So once you've done that, VeriAnalyze, you're ready to deploy. So we have made our final tag selection. We've done a full reader and tag testing, completed. And then we're ready to implement our deployment plan. So, we've decided that our tags are going to arrive pre-printed and pre-programmed from the tag converter, which is great. That makes it a lot easier on VeriAnalyze. The tags are going to be applied by the VeriAnalyze manufacturing line. We're going to test them inside of the manufacturing line as well, and then we're going to package them and send them to customers. So, as just a quick refresher of the webinar today, we went over a quick introduction to JTAC that was done by John Pryor. We broke down the RFID technology in an RFID technology overview, talked about the 3 main parts of an RFID system: the reader and antenna, a host, and a tag. Then we dug a little bit into the RFID tag industry. We saw that RFID tags are made up of tag ICs, some kind of substrate, and the tag antenna. And then we went through some best practices for choosing an RFID tag and finished with an example. So after this, if you wanted to take, what would be the next steps if you wanted to take this information and apply it to your actual application? We would recommend that you really start by defining your goals for an overall system. Make sure that you start broadly and then kind of narrow focus as the requirements really get refined. And then we recommend that you translate those goals into technical requirements, and that's really where JTAC can help take those goals and, if you say that we need to prevent counterfeits, JTAC can take that overall high-level goal, help you narrow it down, and translate it into technical requirements. So at this point,
Steve, if I could just interrupt real quick.
Yep.
Oh, perfect Q&A. We actually just had an interesting question come in, and the question is, what is the expected range of HF and UHF?
Okay. Yeah, this can vary quite a bit, but in general, HF RFID, you might see there's really no minimum read range, but from basically touching the RFID reader to RFID tag out to maybe 5 or 6 centimeters, well, maybe a little bit further, but we're talking on the range of inches from RFID reader to tag, whereas on the passive UHF RFID set, we've seen 10 meters or even further with some very high power and high gain antenna systems.
Great. And then we also just got another question. How many RFID tags can be read at one time from a single reader?
So that varies a lot, again, based on the technology. For an HF RFID reader, you're probably going to see something more like 8 to 10 maximum RFID tags being read at once from kind of a JTAC reader. On the UHF side, you can see 200 to 400 tags being read in a second, essentially simultaneously. So it varies a lot on the technology.
Great. Another question is, how much data can an RFID tag hold?
I think the largest RFID tag I've seen is 64K bits, which would be 8 kilobytes. There might even be some newer tags coming. But you can store a lot of information, but the more information you store on a tag, generally the pricier it gets. So that's something that you want to weigh with overall the price of your RFID tag and how much you need to store all that information. It also takes a lot of time to store that much information on an RFID tag.
Gotcha. Can UHF be overloaded with too many tags to the point where it shuts down?
No, that wouldn't happen. It just, you know, if there were too many tags in the field, it just wouldn't necessarily be able to pick up all of them within a second. Although generally through some motion of either the RFID reader or the RFID tags, we'd still be able to pick up pretty much all of the RFID tags within a field. It would just take a little bit longer.
Gotcha. Okay. Another question that came in was, if you had 20 metal parts in a part with tags, could you read the tag off every item?
Depends a lot on the environment. Sorry, could you repeat the question, Justina?
Of course. If you had 20 metal parts in a part with tags, could you read the tag off of every item?
You should be able to. For that kind of application, I would recommend UHF RFID, hands down, trying to read 20 tags at once. It'd probably be from a little bit shorter range. It's going to depend a lot on the environment. There's definitely a way that we could help build a system where you'd be able to get essentially 100% read range and 100% kind of reliability on that type of system for 20 tags.
Gotcha. We're actually having a bunch of questions come in. This is great. For HF, is there a recommended position of tag with respect to the antenna? Thinking about two antenna planes with respect to each other.
Yeah, that's a good point. So for HF RFID, the tag should always be in parallel planes. So if you had an RFID tag, let's see if I can draw here. It's just going to be. If you had an RFID, okay, there it is. RFID tag 1 here, and your RFID reader, if we were looking down kind of lengthwise at these. So it's a little bit hard to draw here, but I got it. So imagine these lines are actually parallel, and we have some radio waves going like this, back and forth. We want to make sure on HF RFID that the tags are in parallel planes so that they can communicate. The drawing looks a little bit worse than I expected, but that's okay. Hopefully it got the point across.
Yeah, I like your drawing. Very nice. What is practical temperature limit for tags?
Practical temperature limit for tags. I've seen, again, that's going to really be a specialized tag question. I've definitely seen tags that can go up to 350 degrees C. From some really specialized manufacturer. It's pretty high, it's very high, but generally it's not going to be built based on the tag IC, it's going to be based on whatever that tag IC is encapsulated in, whatever kind of material we want to encapsulate that in.
Gotcha. Some other questions are, what are the costs of tags? Is one cheaper than the other, HF versus UHF?
Yep. Yeah, that's a great question. So the cost of tags can vary greatly, but at a really high level, and don't quote me on this, and I don't know if there's any tag manufacturers on the line, tag IC, tag inlay manufacturers, but at high quantities meaning over 1 million tags per year, a simple tag inlay on the UHF side could be in the range of 5 to 10 cents. On the HF side, it'd probably be more like 10 to 20 cents. A lot of the reason that those tag prices change, or kind of the difference in the HF versus UHF, really comes down to volume of the tag ICs that are being manufactured. Retail is really driving very high volume for UHF tag ICs, whereas HF is still being driven by standard applications like libraries and medical devices, but it's not seeing this huge uptick that UHF has seen. Whereas a specialized tag, I know a gamma sterilizable small tag could be even at 100,000 tags a year, as much as $1. And some of the really ruggedized tags meant for oil and gas applications in downhill or downhole applications could be as much as $10. So it varies greatly, but I guess the answer is from 5 cents all the way up to probably $10 for a passive RFID tag.
Gotcha. Okay. Another question is, can you get encrypted tags or encrypt tags yourself to increase security?
So that's really going to come down to the tag IC, again, the brains of the RFID tag. Generally how it works is the tag IC manufacturer will have built in some type of secure protocol that the tag reader would need to be able to support. So for instance, just to use some very specific examples, NXP offers a line of tag ICs called MyFair. Their MyFair Plus tag uses AES encryption to store all the data that's stored on there. All of that secure data and security features are built on the tag and a little bit on the over-the-air protocol between the RFID reader and the tag. So if you want to find a secure tag, you want to look for a tag that has a tag IC that is very secure and a reader that can support the secure features of that tag IC.
Great. And our last question is, can you copy or counterfeit an RFID tag?
It's a good question. The answer is no if you take the right if you're trying to prevent someone from doing that. If we have a very simple RFID tag with no security based on it, yeah, it's definitely possible to change the identifier on the tag for a UHF tag to match another identifier in another tag. But generally, if you have any kind of application where you're trying to prevent that, you can definitely lock in the tag identifier so that it cannot be changed, or you can put in some kind of hidden area, some kind of password protected area in the secure memory that would prevent it from being counterfeited in any way.
Got it. I think that actually concludes our questions at this time. If there are any other questions, please type in at this time. I'd like to thank all of our attendees for joining the webinar today, and a special thanks to our presenters, Steve and John, for their presentation. A recording of this session will automatically be emailed to everyone who registered for the event within the next 24 hours. If any of our attendees have further questions on RFID or any of our other technologies, we invite you to visit our website, jtactech.com, or schedule a tech day with us by emailing us at techday@jtactech.com for a free technology consultation. And if you look up on the screen, you will see all of our company locations along with our upcoming trade shows. Thank you again for attending, and everyone have a great day.